short demonstration of how you can use a game design program to create academic content so that your students can learn it in a gaming format. The program that I'm using, is, you can see up here, is called Gamestar Mechanic. Now, I'm not going to start with a whole explanation of how Gamestar Mechanic works. A great place to start, if you're interested when you've seen this video, is to go to the engagementconnection.com, and read this review, The Amazing World of Gamestar Mechanic. It'll give you a lot more background on the game. For now, you're just going to have to understand that this is a demonstration of how one could use a game to teach some specific academic content. And so let's look at that content. I've selected some math content, and it is going to be teaching young students how to plot ordered pairs. And it's appropriate for grade 6 or 7 math class. And so we will be graphing ordered pairs, and we will be connecting ordered pairs to create straight lines. And so I have some directions here for them to follow, and I'll be coming back and forth to this so that you can see how these work out. Now, I'm simply going to go down here and make a new game in my Gamestar Mechanic screen. When you see it comes up, you can see why it lends itself so well to math. Gamestar Mechanic is built on a grid. Obviously, wherever you have a grid, you can now create a multitude of math possibilities for students to work with. In Gamestar Mechanic, I have a number of tools to play with over here on the left that I have learned by going through my internship, and that is what I will be doing to create this game. So, pulling up my instructions, it says, using yellow blocks, create a horizontal line of blocks in the middle of the graph. Okay, so I'm going to take yellow blocks and create a horizontal line in the middle of the graph. I click on it and move it, and I can drag it to save some time. All right, instruction number 2. Using brown blocks, create a vertical line of blocks in the middle of the graph. So I come back to my graph and I pick my brown blocks, and I'm coming to the middle, and I'm going to go brown blocks down the middle of the graph. Very good. And notice it sort of skipped over my yellow block for me there. Now my next instruction is using cloud blocks. There's a cloud block right there. Place the following ordered pairs on your grid. So away I go. I pick a cloud block, and my first ordered pair was -2, so there's 1, -2, and +4. 1, 2, 3, 4. Place a cloud block. My next one is -2 and -4. So there's -2 and -1, 2, 3, 4. Place my cloud block. My next one is +5. 1, 2, 3, 4, 5. And +5. 1, 2, 3, 4, 5. Now, I can go through and place all the ordered pairs here that were in my instructions until I placed them on there. If you were to pause your computer at this point and study the picture, you would note that all of the white cloud blocks match the required ordered pairs on the assignment sheet. My next set of directions is to study the grid, and you should see possibilities to connect blocks to create straight lines. Create as many lines as you can using point items or enemies that move between the blocks. Okay? So, using point items or enemies that move between the blocks. The student knows that to find the points items, they click the item block, and they have 2 possibilities here. And so we begin by choosing this point item and then drawing a straight line between the blocks. The student also decides to be a little creative and switch to the larger point one to create a straight line between these 2 blocks. Now the student decides to switch to the enemy sprite, and he takes the enemy sprite and he sets it up right here, knowing that it will now scroll between those 2 blocks to meet the requirement. He sees another opportunity down here, places the sprite there, knowing that it can scroll back and forth. Interesting to note, and this is on purpose, that the student neglected to complete a straight line between these 2 blocks. And so the teacher could use that later on as a coachable moment. It may come out in a peer review. But the student has made an effort to meet the requirements now of connecting as many blocks as possible with straight line points or enemies. Having met the requirement of placing the cloud blocks in accordance with the ordered pairs, having placed points to connect some cloud blocks in straight lines, or enemy sprites to place certain cloud blocks in straight lines, the student turns to the instructions and sees that there's still some work to be done. Place a goal block on the grid at this location. So the student goes to a goal block and goes 1, 2, 3, 4, 5, 6, 7, 8, and then negative 1, 2, 3, 4, 5, 6, and places a goal block in this corner. It also says to choose an avatar and place it at this location, negative 7, negative 1. So we click on avatars and we choose an avatar, and we're going to go 1, 2, 3, 4, 5, 6, 7 to the negative and negative 1. The student then checks to see what the next requirement is, which is to take a picture of your game and turn it in. And so the student goes and simply does, on a Mac for example, Command-Shift-4. He would use a clipping tool on a PC, draws a box around his game, lets go, a picture is taken that now can be turned in digitally or can be printed and turned in for peer review, for corrections, or however the teacher wants to use it. Could even be used as an assessment piece to show that the student did or did not meet the requirements of plotting the ordered pairs. Now that the student has finished the formal requirements, it's time to move on to the real beauty of Gamestar Mechanic. The directions now give the student the opportunity to finish building your game using your own creativity. You may add any other items in your inventory or set any rules to complete your game. This can be the most engaging part of Gamestar Mechanic, where the student may now move on, add additional components to their game so that they may create an exciting game for others to play. And so I'm going to go about designing and finishing the game. I'm going to use my creative and problem-solving and critical thinking skills to come up with a final game. I've decided in my mind that I want the avatar here to have to travel to all 4 quadrants to gather points before they get to the goal block. To do this, I've added additional points in each quadrant, so now there are point items in all 4 quadrants. I've also set a requirement that they gather 160 points, and I now know that the avatar will have to go to each quadrant to accomplish this goal. Because there are enemies which can cause problems, I've given the avatar 3 lives to play with. And to make it a little spicy, I've added a 1-minute timeline. So when the game is ready to go, the avatar will have to go between each of the 4 quadrants, avoid the enemies, gather all the points to capture the goal block. Here we go. This is it. I'll actually go into play mode and play the game. Notice that the grid lines have gone away and I'm just moving down, so I'm going to come down here, grab my first set of points. You can see I've gone up to 4 points on the point thing. I got to get out of here. I can go off one side and come in the other and come down and grab some points. Now, why don't I go for the goal block? Because I haven't got all my points yet. And so I don't have enough to go there. I'm going to come in the other side. I'm going to go risk here and try to squeeze by this. Oh, he got me. Notice my lives have gone down from 2 to 3. Let's see here. I still don't have enough points. Watching my time, 27 seconds. Okay, but now I still have a problem. I got to get... I'm almost out of lives and running out of time. Coming over, bingo, I got it. And so I just won the first level of Gamestar Mechanic. So there you have it. A introduction to how a teacher creating the format for the game, designing the resource, if you will, has created an opportunity for students to both play a game with math content and then to go on and use their creativity. Numerous variations of this that you could do. You could create a game and have a student analyze it and provide you with the math content. In other words, work backwards. Here are a series of clouds posted to the grid. What ordered pairs do they represent? I also want to say, and I'm going to back out of this to my workshop and come back to a blank grid again to show you, is that other possibilities with math, that anytime you have a grid, you can create all kinds of graphs. So, I mean, any math teacher can look at this that I have just posted here with different colored blocks and see that this could represent a sort of a graph. Also in Gamestar Mechanic, one of the things that you can use are what they call message blocks. So I could even put a message block in here as you see me moving these around. It's not important right now that you know how I'm doing this. It's just to see what the possibilities are. But these message blocks, for example, could be used to convert this left side into a scale. In other words, this could be, instead of 1, 2, 3, 4, 5, 6, this could be 10, 20, 30, 40, 50, 60. And in the game, if you were to click on this block, it would tell you what the numeric value is. But you can see you begin to do graphs. So you could present a student with any word problem requiring that they create a graph. Once they create the graph, they do the screenshot, and then they can use their creativity to build a game around this mathematical content. There you go, Gamestar Mechanic and some middle grades math content using gaming for teachers to create the resource that the student uses to master the content.